Let's design a common emitter amplifier. Now we're going to swamp the emitter or give it emitter feedback, or we'll call it negative feedback. Now the reason we do that is that this R prime E, that's the emitter diode junction AC resistance. And if you don't have a resistor from the emitter to ground, this is the only resistance you're going to have here. Now over on this graph over here, this going up this way is the emitter current, and this way here is the voltage from base to emitter here. And then we have our curve here. Now this R prime E, that's the slope of a tangent line to that curve there. And it rides on the bias point, but that bias point changes as our AC signal comes in, okay? And so that the slope of the line is going to change. And as that changes, the smaller the R prime E, the bigger the gain. So your gain is going to be going up and down, changing with the signal coming in, okay? So what we want to do is we want to, swamping this R prime E by making RE much larger, okay? And that stabilizes the output against variations in this R prime E, okay? And that reduces distortion. But it also reduces the gain, okay? Now, sometimes we'll call it negative feedback because your signal coming in and the signal going out, they're 180 degrees apart from each other. So when this side's positive, this is going to be negative, and we're going to push that back over here. So sometimes we call that negative feedback. Now, we don't have to worry about this R prime E or any of the derivatives here or anything like that. We're just going to swamp it out, and that's going to eliminate that. We're just going to make this big enough so we don't have to worry about it. So what we want to do is we want to select the VCC, our voltage. I'm going to pick 9 volts, so I can run this thing off a 9-volt battery. And we want to choose our collector voltage, the voltage we're going to get right here, the DC voltage. And we want that to be half of that VCC, half the 9 volts. So it's going to be 4.5 volts. And that's our DC bias level here, 4.5 volts. And that allows the amplitude, the amplifier output to ride up and down on that DC voltage there. So go down to 0 and up to 9 on that. And then we want to select the collector current. I picked 1 milliamp. Now, you can use 10 milliamps, probably be better. But the collector resistor, so that's this one here, that's going to be equal to the VCC minus the VC, voltage across there, which is going to be our 4.5 volts, okay? And divided by the current. And we're just picking 1 milliamp. So here it is right here. So if we divide that out, we get to 4.5K. We don't have one of those, so I picked a 4.7K resistor. Okay. Now the base current, we want the base current to be half the collector current divided by the gain of the transistor, okay? So again, we want to take that in half so that we can vary the signal coming in. And the HFE, or the gain of the transistor, I'm going to pick 100. That's pretty typical of a transistor, and I don't think we can go wrong by using 100, okay? So we divide that out, half the current divided by 100, and it comes out to 0.05 milliamps, something like that, okay? So now we want to find the emitter resistor, okay? So for base stability, 1 volt is good, okay? So if we drop a volt across here, that's going to be pretty good. You can do 0.6 volts or a volt across here, but we're picking a volt to put a volt across here, okay? So what we want to do is we want to divide that 1 volt by our current through here, which is going to be the current through the collector current, plus the current going through the base here, which is so small that we're not even going to worry about it. But if I divide that 1 milliamp into 1 volt, I get 1K. So our we're going to have this resistor here is going to be 1K, okay, 1,000 ohm resistor here. Now the we need the voltage on the base here to be a volt higher than this voltage down here. We got to pass some voltage current through there, right? So I'm going to pick 2 volts here. It's got to be a volt higher than this. So I'm picking 2 volts on here. And then that means I want to drop 2 volts across this R2 resistor here. And our current is going to be our current into the base, right? And then we want more current to flow through here, so we have plenty of current to feed this thing with, right? So we're going to make this the current through here 10 times greater than the base current here, you know. And so if I multiply that out, it comes out to 4K, which I'm going to use a 3.3K ohm resistor there, okay? Now up here, we have the same currents flowing through there and 9 volts across there, so there's going to be 7 volts up here. So we take our 90 minus our 2 volts down there, that's 7, and we divide it by our current, and that's going to be 14K. So I only had a 15K, so I put a 15K up there. So that's it. That's how you calculate all the resistance for those. And on this side here, I'm going to use a 1 microfarad capacitor, and I'm putting in a 1000 hertz signal in there, and so at 1000 hertz, going to have a resistance of about 160 ohms on here. And on the output, I'm using the 10 microfarad capacitor, and that's only going to be about 16 ohms out, so that's going to work out fine. This doesn't allow any DC current to go back into my input over here, and keeps it out of the output over here. So I built it up. This is it here. Doesn't look like much. You know, 4 resistors, a transistor, and a couple capacitors. And then I put the signal on the scope, and this is what I get here. This one's the input, and this is the output. Gain's not that big, but you can see it. That's you know, no distortion. Came out with a nice nice sine wave coming out there, you know. Now, if you want to increase the gain, you can take a capacitor and put it across this resistor, and it takes the AC signal and puts that to ground through here, eliminating the DC part of it here. So we just put a capacitor across there with the resistor, and you can increase the gain on there. Now, I did run it at 5 volts, and at 5 volts, of course, you can see that it's clipping it off because it can't get up to my, you know, I don't have the 9 volt swing anymore, so I can only go 5 volts peak to peak, so that's about it, you know. Now I could redo some of the resistor centers so it would work on 5 volts, but it's working on 9 volts right now. So that's it right there. Thank you.